All right, time for another DraftPhysics.com, debatephysics.com also, but people aren't up to some sort of reasonable response to the assertions I make, so we're stuck with the unreasonable. And so I'm with I guess it's a show of some kind. Anyway, so somebody, Mr. Dan, Olga1, great name, just brings. Anyway, who's saying what? So there's I've put this, it's the same argument. I'm going to make it in a third video. The simple little scale argument. Okay, you put one mass on, they say it's 1 unit of energy. I just put a second mass on, they say there's 4 units of energy. Complete nonsense. That's what physics says. So this is the same argument as do you really need 100 times the fuel to spin a motor 10 times as fast? Or does something spinning 10 times as fast have 100 times the energy or the ability to cut wood or the ability to do work? The assertion is nowhere close. No, not even. It's silly. That's the argument. All right, if you put twice as much weight on a scale, you get 4 times the energy, question mark. That's what physics says, yes. You now have in the spring 4 times the energy of a 1 unit of compression. 2 units of spring compression is 4 times 4 units of energy. Okay, that's absurd. That's physics. But I guess since the sign above the head says kinetic energy versus momentum, yeah, that's what it does. You talk about kinetic energy. You talk about kinetic energy. You probably won't say you're talking about, but okay. If that's the case, well, duh. So you saw the sign above my head, all right, and I'm clearly talking about units of energy. So where's the confusion? You're pretending there's a confusion? All right, if that's the case, you don't get 2 extra units of energy. So says you. That's what physics says. I'm arguing what physics says. So you explain where physics doesn't say that. The only way you can, there's no other, they have no other choice. Okay. It takes 2 extra units of energy to accelerate an object from 1 to 0 units of speed versus 0 to 2 units of speed. So he's just saying it takes twice the energy to go twice as fast. Isn't that what you just said? It takes those 2 extra units of energy to accelerate an object from 1 to 0 units of speed versus 0 to 2 units of speed. No, can't make any sense. It takes 2 extra units of energy to accelerate an object from 1 to 0 units of speed. So the first one put 3 units of energy in? How is this relating to the video in any way? And how does this make any sense to anybody? Going 10 miles an hour is twice as hard as going what? If I went 20, somehow the first 10 miles an hour cost me 2 units of energy. You don't have any evidence of that. Versus 0 to 2 units of speed. Versus, there's no versus here. You haven't told me what 2 units of speed requires. All right, whatever. And yes, it would be religious to just accept it. But we don't. We observe it a million times a year in car crashes. So show me that, please. That's what I'm desperate to see. You can't find a link to one of these car crashes, these magical car crashes where momentum doesn't completely control everything that happens? Show me, okay? I mean, I could show you the Mythbusters, okay? They crash a car at 50 miles an hour and it crashes that much. And then they crash a car at 100 miles an hour and exactly twice as much crashing. Exactly half the amount of car is left. Yeah. Twice as much removed car, let's say. So where? So high school experiments, yeah, that's with those little rickety metal-wheeled carts and with flunky little air tracks. So impact tests, where's that? Show me. Ballistic pendulums are exactly the opposite. They clearly show you lose all the kinetic energy. You conserve almost all of the momentum, and you lose all the kinetic energy. Correct ballistic calculation. So show me. This is just lying. You're just lying here that any of this stuff shows any of your crap to be true, you moron. Sorry, but this is just bullshit. You just type this bullshit that you have evidence somewhere. Show the fucking evidence. For 2 fucking years, everybody's asking, where's the fucking show the experiment? Show the experiment. Well, what are you doing, that asshole? And probably at least 1,000 other instances. So what a pile of motherfucking cunt shit. You sit there and talk about, yes, it would be religious to accept it. And what do? You just say, I'm supposed to accept all this crap you just spewed about evidence that doesn't fucking exist. God, what an asshole. To religiously hold a view is to keep the intuitive view despite all observed evidence available. Where is this observable evidence? Show it to me. Link to it, you fucking little weasel. Sorry. But this is just such bullshit. I mean, here somebody's accusing you to have a dogmatic religion. Oh, yeah, well, show me Jesus walking on the water. Show me the Holy Ghost doing anything. Show me something, fucker. And what do? You just recite that he walked on water and he, made lots of fish and bread and such. He gave everybody a fish sandwich. He did he raised the dead. He did all kinds of cool stuff. Yeah, you're just saying so, fucker. You're not showing so. All right, so Lewis replied, if you put twice as much weight on a scale, you get 4 times the energy. I think he is talking about potential energy. I'm not, why would you even say that? I'm not talking about anything called potential energy. It's a lie. There's no such thing as potential energy. There's just active energy that you can let out a door. The bees are always buzzing, okay? You can poke the hive and a bunch of bees will fly out, okay? It's not fucking goddamn potential bees. Oh, anyway, the spring E equals 1/2 kx squared. Well, and again, that's really not the spring. The guy who invented this shit didn't put any square on any of the x's. It's not his theory. All right, anyway. Let's see, if you read more of the first line of my OP, whatever that is, your object poop, I don't know, you will see that I'm not only aware of it, but also explain it easy and understood language. What did you explain? Where's your OP? What's your OP? Where the fuck is an OP? It certainly wasn't in this fucking bullshit here. You didn't show anything. You didn't explain anything. You just reasserted crap. I'm saying show me it taking 100 times the fuel, the energy, the electricity, to spin a motor 10 times as fast. Show me where that happens in reality somewhere. Or just show the 25 thing, okay? The 5 times as fast, 25 times the energy. Show me. You fucking assholes. All right. Let's see. And then Lewis says, by that logic, adding a second weight would add less energy to the spring because the spring had been compressed by the first weight, reducing the distance. Yes, that's true, but why I don't need that technicality, frankly. We know that the scale, the spring itself, doesn't care about how much distance you lifted to get to the top of the surface. It just cares how much weight is on top of it. That's all it cares about. How much weight is on top of me. It doesn't care about how it got there. So for the spring, it's not a relevant fact. All right, so I think that's it. I mean, there really aren't any other comments. So somebody does get the galactic spin thing, which is good. Now, he says stuff here that was, okay, so I'll read it because, yeah, he's making a mistake. Great video, logic as always. What if we apply the same logic to conventional model of the sun? The problem with applying the same model to the sun is the sun is incredibly dense, and guess what? All the stuff is moving towards the center. So as the gravity wears out, the masses moving start pushing you. So you start getting pushed by actual atoms instead of a gravitational force. So the pressure inside the sun is intense, and it's coming from all directions. So it's not pressure like it's going to move you in a direction. It's pressure like it's going to crush the fuck out of you. Okay, so the pressure on the inside of the sun isn't gravitational. The pressure inside the sun is created by a bunch of atoms all moving like this. Yeah, see, they're all moving in right for you. They're all heading right for you. All right, we are told that gravity at the center of the sun gets so strong. Now, see, that's not true. So I don't know if they actually say gravity at the center of the sun gets so strong. If they do, then obviously making a mistake. The pressure gets really strong because you have a bunch of atoms above you and below you, and the below you ones in this case are also pushing you up. So you're stuck in a vice. It gets so strong that nuclear fission takes place and two hydrogen protons are fused together into a helium proton. Well, that's not exactly how it works. There's no such thing as a hydrogen proton and a helium proton. The only thing getting fused is the nucleus, that is the relationship between the protons. As you pointed out in this video about gravity distribution in galaxies, the same logic should apply to the sun. So the same logic does, it's just the fact is the galaxy doesn't have enough density of material to create pressure. So you're not going to get pushed by the other suns. They're just not going to hit you and push you. Okay. And there should be less gravity at the center. So again, there's less gravity, but there's a lot more matter heading for you. There's a lot more momentum heading for you, if you want to put it that way, of the sun than at the surface. In fact, at the center of the sun, all the matter would be outside you, and I would think gravity should be more like pulling you apart. Yes, if that would be true if the atoms weren't smashed into each other. But the fact that they are physically pushing on each other is the problem. In all directions instead of crushing you in. Their explanation of nuclear fusion occurring at the center of the sun seems less likely to be true. So I think it's a perfectly reasonable explanation to understand that the chemical pressure, if you want to call it that, the physical pressure, increases at the center of any gravitational body because all the stuff is in fact moving towards the center. All the weight, all the momentum is crushing the center. It's two forces opposing each other, and they don't cancel. They actually crush. Okay? They crush whatever you put between them. They don't cancel. They crush. I would love to hear your thoughts on the matter. Okay, well, you just heard them. All right, let's see. Just want to hear Isaac Newton react to these people using Leibniz's equation and saying it was his just once. Yeah, it'd be nice if we could just dig up old people, dead people, and have their ghost curse the fuck out of us. What the fuck are you doing? I could do all of this work and you turn it into shit. You fucking assholes. All right, so... yeah, I responded to this 25 times. Oh, I asked the guy, yeah. Yes, Newton knew that. He mentioned that in the Principia, and he said it was the truth. Principia is a free PDF. Yeah, I read Huygens and look for the part about various people communicating their discoveries to the Royal Society. Yeah, he's talking about the experiment. So he's not talking about the little line where Huygens says mv squared is conserved. He's talking about the fact that Huygens agrees that, 50 in, 50 out. So he's talking about the substance of what Huygens was talking about was his observations of pendulums. And I don't think Newton associated with some mv squared theory. He wasn't talking about creating free momentum, in other words. That's not the part, so you show me where Huygens described the experiment that makes the free momentum, and then we can have the conversation. That somehow Newton knew that. Newton wasn't aware that Huygens was an mv squarer. It seems kind of obvious because he didn't react to it until Leibniz brought it up. That's the simple truth. Okay, I mean, nobody panicked over Huygens' statement, 30 years earlier. So Huygens says it 30 years earlier. Nobody pays any attention because I guess Huygens must have been a boring read. And it wasn't until Leibniz showed up and reasserted the point and called it the living force that everybody reacted. So that's sort of the facts of the case. All right, so I asked him the simple question. Do you think it takes 25 times the fuel to spin a motor 5 times as fast? Just answer the question. If you believe that, then I can just write you off as a nut. He finally responded. Okay. And then I asked him, so if a 10 mass with a velocity of 50 hits a 30 mass with a velocity of 50, moving in the opposite direction, so this is the two pendulums coming right for each other, okay, with a total of 200 momentum, You actually believe that only 10 going 100 will leave the collision, that only 100 momentums leave. So 200 momentums go in, only 100 leaves. Okay, I think the concept of negative momentum is silly unless you can link to some credible evidence that momentum can cancel. It's just dogmatic pseudoscience. Yes, momentum never cancels. It always applies work to something. If it doesn't apply work to something, the energy has to be retained. It has to still do whatever it was doing. Oh, good. I've got a whole big pile of crap here to read. All right, if you're talking about accelerating the motor, I'm talking about spinning at a speed. I mean, what? How? Now, they can't even handle this. It's going 1 revolution, okay, a second, and then you make it go 5 revolutions a second. Is that fucking over your head? All right, the motor to those velocities, then yes. Okay, so I mean, he's an idiot. He's a fucking lunatic. How the fuck could he believe that? And to other questions, yes, if the collision is elastic. So you're an idiot. I mean, on the first cause, I can just say you're an idiot, right? You really think that if I drive down the highway at 50 miles an hour and maintain that speed over all the obstacles and whatnot, that I'm going to use 25 times the fuel? You're a fucking lunatic. All right. So-called negative momentum has been clear since Newton and others. So what a lie. Okay, so it's just a lie. Newton didn't say you don't have to conserve momentum. He knew that if you had a crash between 2 objects, you have to use all the momentum. You can't just make it disappear. And you certainly can't make new momentum appear. Well, don't even bring up that little weasel. Tried to explain Newton's pendulum experiment to you. He didn't explain anything. He just distorts reality. But you completely ignored it. I'm completely ignoring imbeciles that have been repeatedly wrong. I mean, over and over and over. Simple mistakes, and they keep declaring they've proven something. They've made disgusting mistakes. Okay, and then Dispar Lab, to bring him up. Dispar Lab doesn't understand the arc thing. He doesn't understand that distance this way doesn't mean anything to a pendulum. It's the distance up that means something. That's the part where they're actually losing velocity to gravity. They don't lose any velocity when they're going this way. They only lose velocity when they're going up. Dispar's an idiot. All right, has just created an excellent duplication of that experiment. Bullshit. Slow motion and all. Bullshit. Just a smaller scale. Yeah, tiny scale where he doesn't even... If you're talking about that, I don't know what this is, 9 hours ago. So I don't know if there's some new experiment that's likewise going to be completely flawed. He left up that silly carton experiment he did. He was proving it's the same energy by putting the carton in one place and the 2 pendulums have completely different arcs. I mean, that was so bad. Measure the distance over a few frames and you see for yourself. Fuck you. You can also measure the heights, but it's a bit more difficult. Oh, that's the only thing that matters, fucktard. With a pendulum, the only thing that matters is the height. That's where the friction is with gravity. That's where you're losing the energy, is the height. All right. Let's see. Difficult as the differences are small. Yeah. Well, like I said, if he just measures those correctly and gets the angles right, it's all calculable. All right, the results are what Newton, Huygens, and modern physics predict. So again, Newton does not predict it, so it's just a lie. Newton clearly stated in overt language, twice the force, twice the velocity, 3 times the force, 3 times the velocity. You're just awful, disgusting liars. What a coincidence. Yeah, there's no coincidence. You're just... disgusting liars. I mean, even the retarded Wikipedia page concedes that Newton believed in momentum. Ugh, it's just so disgusting. So, Elizabeth, yeah, your comments are sort of annoying, frankly. I'm not a professor, so I really don't like being called it. Okay, I don't even like the whole concept anyway. Even if I was a professor, I probably wouldn't like the term. So all these ideas of quarks, gluons, bosons, etc., I mean the standard model, are not true. It is nonsense. I mean, how many, excuse my French, but how many fucking times have I said it? It's in every fucking video I make just about. And it's certainly in the video I linked you to, okay? So I've previously linked you to the starting video that explains there's force and there's matter. They're two distinctly different things, and they're in something called space. And that's all there fucking is. So I made it kind of clear there's just two kinds of force and just two elemental kinds of matter, electrons and protons. There are no other things. There are no gluons or bosons or neutrinos. All of that shit, okay, is just a measurement of speed. It has to be something moving that speed. So it's an electron moving that speed, or it's a proton moving a specific speed. And they've decided because something's moving a specific speed, we're going to call it a positron instead of calling it a proton. Oh, fuck. Well, anyway, so I already did this shit. I'm learning by myself. Well, I don't care. It's not my job to tell you what to do. It's not my job to control your life, okay? So it's just not my job. I don't want responsibility for it. I think I'm making my videos as clear as I can make them. There's a whole bunch of those 5-minute videos. I'm really just talking about kinetic energy and photons. I really don't give a shit about fucking anything else. I'm arguing conventional physics. I'm not here to tutor you on something else. I'm here to point out the flaws in their theory and the strengths of mine. That's it. Okay, anyway. Annoying. Alright, so I did get a fucking email from that fucking turd Gosling again. So I think I'll just illustrate that real quick. Oh, he's such an asshole. I mean, I politely asked him to fuck off, and he won't do it. Alright, so in the previous video, he just posted a link to his fucking idiotic experiment. So let's just illustrate it quickly. And I'll point out all the reasons why I didn't even, I shouldn't have to even pay any attention to it. It's so bad. So he measures nothing. You know, it's got no precision to it at all. So he's using a ramp to hit a pendulum now. Okay. So we've already got enough problems with other circumstances, and now he's going to add. So the idea is you roll a heavy object and you roll a light object. Now his light, you know, it happens to be smaller. So he made for some wacky reason, he made the light object bigger. He put foam around it. All right. So this is supposed to be a 4 mass, I guess, and this is supposed to be a 1 mass. So this is the wacky thing he did. So I think he got the 4 times the height right anyway. So he's going for twice the velocity. And he's going to have these things bang into a pendulum. Now, as already pointed out, this isn't the way you want to do the experiment because the momentum will never be what you think it is. The velocity this way won't just be the only momentum these objects have. They also have rotational momentum, okay? So it's stored in their rotation. So their total momentum is a bigger number if you can extract it, and that's the key point. Now, if you have a wheel with an axle, okay, the idea is and then you hit something here, and this is connected, right? So the car is connected to the axle, the piece of stuff. Well, then the energy of the rotation goes into the axle, okay? And so now the car, if it hits something, you'll get all of this energy back into linear force. But if you don't do that, right, and you just have a rolling object hit something, it's rolling down, okay? The velocity is down. The velocity isn't forward from the angular rotation. So the angular rotation is going to hit your pendulum and it's going to want to push it down. It's not going to push it forward. It's going to stretch your string, okay? It's going to do lots of things, but it isn't necessarily going to be able to convert it very efficiently. So the point is, it's not going to make an efficient conversion. Now, if you put a big piece of foam around it, well, then the foam will stick to it, deform, and be able to push it a little bit better, but it's only a little bit better. So the angular momentum gets essentially, clearly you don't conserve the angular momentum because you're going to create a bunch of weird distortions when you're pushing down on the pendulum instead of pushing forward on the pendulum. So that's not going to work at all. All right. And so, again, so these velocities are going to be who knows what, okay, in terms of being correct. You didn't measure any of it, and he didn't measure how far it moves. He didn't measure this with any precision, and he clearly didn't measure how much Like the force mass obviously can't give it more velocity, right? When something hits something, a bowling ball hits pins. If the bowling ball is going 10 miles an hour, the pin kind of flies off at 10 miles an hour. If the bowling ball is going 30 miles an hour, the pin can fly off at 30 miles an hour. This slow moving thing can only give this a small amount of velocity. It can't give it 40 miles an hour. Okay, say it's going 10. It can't go 4 times 10 and give it 40 miles an hour. It can't do it. So it's going to have a whole bunch of energy left over. So it's going to keep going. It's going to hit this. This is going to move, and it's going to continue to go in the same direction because it didn't give its energy to the one mass, you idiot. All right, and the opposite is true for the lighter thing. Obviously, the faster thing can hit something, give it a bigger, substantial portion of its energy, and it will have less energy. And it, in the case of his thing, because you put foam around it, it'll actually bounce backwards because you've created a spring, okay, and the spring is going to store some energy and then give it to both sides. I mean, we've been over this stuff so many times, and it's like, oh, come on. You're not going to sit there and argue a video that's this bad. But he did. All right, and so I said, you've got to be kidding. You already know that uneven masses do not exchange energy completely. You have to measure the energy of both objects after the collision, not just one. That is, the pendulum's motion and whatever you hit it with, you have to measure its motion too, because that's the total momentum. The total momentum is going to be in one object or the other object. It's not going to be in just one object. I'm really not interested in communicating with you. So he didn't care that I'm not interested. All right. We already know that. So this is days later, like a week later. We already know that uneven masses do not exchange energy completely. So he quotes one part of my statement. And so he converts that into saying, so you're now denying your assertion that a one mass dropped 1 height and a quarter mass dropped 4 heights. So this is the same thing as saying 1 pound dropped 4 feet, 4 pounds dropped 1 foot, are the same because it cannot be tested? No, I'm not saying that at all, you fucking retard. I'm saying if you're going to do a collision, collisions aren't, they're not Newton's cradle simple in every case, okay? Because you don't have equal units. You can't put uneven masses on a Newton's cradle and expect it to go back and forth and work and all of that crap, because it doesn't. All right? The energy gets changed into very different speeds. I mean, God, you just can't be this fucking stupid. Right, he is this fucking stupid. The fact is look, the 16-pound bowling ball going 8 miles an hour, I drew that whole diagram. I explained to you exactly how the energy is disposed of. And the 8-pound ball loses a lot of energy in the beginning and then, tails off at the end. And the 16-pound ball does exactly the opposite. It goes so much more a less uneven line, and because it's giving away half the energy to each pin in the beginning, but in the end it's giving away a lot more energy as it slows down than the 8-pound ball that runs out of all of its energy because of its high velocity. So but the space under the curves are exactly the same. It's just they look different. The 8-pound ball, yeah, big, starts off going very fast, ends up going nothing. And the 16-pound ball, a much better curve, much flatter curve. All right. Anything else? No, there's nothing. I don't think there's anything else here. So there was something else I wanted to get to. Yeah, so there was this from the website. Somebody linked to this and said this experiment proves that you can conserve both energy and momentum. So it says the conservation of energy and momentum in Compton scattering. So it's a terrible example because when you're talking about photons moving electrons, there's perfect efficiency. So there's no friction. There's no losses anywhere. All right. So in a sense, it is a Newton's cradle where uneven masses are able to exchange energy more completely. So in a sense, how to describe that? It still doesn't make any sense, but really when you're comparing the frequency of the light and claiming it has more energy, again, my argument is it doesn't have any more energy. the frequency doesn't mean it has more energy. It means it can tip electrons better. So the absolute fact is that the photons all have the same energy. It's just how they use the energy that's different, right? So again, the tipping point argument is I have 3 baseballs and I want to tip something over. If I throw the baseball slowly, the object tips, and then I throw the ball again, okay, the object tips, and then I throw the ball again, the object just tips. But if I can throw the balls quickly, while this is still moving this way, or because of one oscillation, it moves one oscillation and now it's going this way, and I hit it again, then I'm going to make it tip over. Then I hit it with the 3rd ball and it tips over. So if I hit at the resonant frequency of the vibration of an object, I can make the object move, okay, because I'll be adding energy to its system rather than subtracting energy from its system. So it's that simple argument. So this really isn't applicable. We're looking for tangible physical evidence in the real world, not experiments inside of beakers. It's just bullshit. I mean, it's not even a beaker, but we're not really talking about banging photons into electrons. That would be my response to you. This isn't really evidence, because their physics doesn't even calculate the momentum correctly. Again, they think the raw materials of the photon, that is just the quanta that make up the photon, innately have more energy because they came in a faster sequence. So ... is more energy than ... That's their understanding. So of course they've got this all backwards. All right. It's just 3 dots. It's not more energy. It would be the simple argument. I guess we'll just say it that way. That's the simple argument. All right, so here's the Dispar lab video. Complete crap again. So there's no measuring devices anywhere, okay? Just none. So you can't measure anything. And you certainly can't measure heights, okay? You should at least try to mark the center of the masses of the marbles. And so what value could this possibly be? I mean, why are you convinced? Why can you say to me, oh, it's moving versus 1/4 the speed versus half the speed? Okay, so let's start it over. All right. And your obligation is to explain how you can tell that this marble is not going 4 times as fast as the recoil. The difference is do the 2 marbles, when they come together, are they moving 1/4 of the speed or are they moving twice the speed? That's your obligation. Oh, sorry. I'm sitting here. There's a cat on the driveway. Interesting. All right. I'm back. Continuing. All right. So we'll sort of see the speed of the thing going in. And, okay, well, that's pretty fast. Yep, fast. Okay. Who knows? All right. Now they hit each other, and their theory is that now we're going to create twice the momentum. So one goes in with a momentum, and now twice as much momentum is going to be pushing out. That's their theory. And now it's going to come back together, and only half the momentum is going to come back out. So it has twice the momentum. Now you've got a car going 150 momentum and a car going 50 momentum. They're going to hit each other, and only 100 momentum is going to come out of the crash. That's their theory. That's what they're defending. And somehow they think this is going to prove it. So that's just going back to what it originally did. So that's the high velocity, high height again. And now we have the little shorter height. So how did he do these measurements? They're constantly accelerating and decelerating. So understand, frame rates aren't going to help you much here because you can't get the velocity at impact. You can't get the velocity when they're leaving. You have to get some slower velocity going out or some faster velocity going in. You can't get the accurate velocities. So you can tell looking at that, yeah, it's definitely half the speed. Yeah, sorry. I don't think you can tell. So apparently this was supposed to be good enough evidence right there. That was supposed to be conclusive proof that they're going half the speed of the original object, this video. I don't think so. And it's really, again, it's not just about speed, it's about height. So the real thing you have to measure is how much height, because you were talking about how they lose their energy and how much energy they lose. And that's decided by how far you go up in the gravity. So how much fuel is in the rocket will tell you how high the rocket goes. So you're really trying to measure its momentum. How much momentum did you give it? And so you go by how high it goes. So how far it goes across the bottom of the arc doesn't mean anything, because that's all just real horizontal movement. How high it goes, that's the part that matters. All right, so this is nothing, right? So this is a proof of some kind. No analysis, no anything. So let's see if he at least has the length of the pendulum. No. So he doesn't even tell us the length of the pendulum. Yes, okay. So you can use arcs to tell height. So if you have the length and you can get these numbers somewhat accurate in terms of how long the string is, and then you can figure out the angle, okay, then you can figure out the height. But he didn't provide that information. All right, so bullshit. So I think that's it. I don't think there's anything else. Oh, back. Yeah, there was one comment on the video on the website. Said something like, why are your web page all fucked in and shitty? Yeah, whatever. Because most people, the fact is, most people now view the internet on a mobile device. And mobile devices are basically 800 resolution, yeah, at best. And so this size is probably best for that purpose. And I frankly, personally, don't like to have to read text going across a big giant screen. Okay, it just messes up being able to read, because the lines are so far from each other. You end up reading the wrong lines and all that stuff. So I personally think this is much better. It's much easier to read lines that are not too long. 70, 80 characters, 100 characters, something. I can't remember what the rule is, but that's sort of the ideal. So that's another reason. And it works just fine, frankly. You can hit the links. They're big enough now on the phone. You can hit them pretty easy. The videos play. So what's the problem, right? What's your little Weasley complaint, really? Oh, you're just trying to hurt my feelings. Is that what it is? Oh, okay. Well, you didn't work. So try again, because that didn't work. Oh, God, people are just such assholes. It's just so depressing that there's so many assholes on this planet. Ooh. Ew. Damn. I mean, it just sucks. I mean, it's like diseases and weeds and bad smelling things. It's just, why? It's like living in an environment that has all kinds of predators in it, and you just don't want to take a walk outside because, I have to fight all the predators, the mosquitoes and the wasps and the bears and the, tyrannosauruses. And I don't want to bother fighting all that shit. Just ruins life, all this fucking human garbage that we have to accept as part of the flora. Yeah, fuck it. Ugh. Clean house. Anyway, till the next time and such, so forth and whatnot. Our civilization ought to clean its room.